Hi, I'm Ivan Morgillo, and I'm the author of Rx Essentials for Packet Publishing. My most popular app is a personal project. It's a greatest ebook for Kindle, and it's a companion app for your Kindle. It's pretty popular. In the next half hour, we are going to talk about, you are listening and learning, Android Reactive Programming with RxJava. We have a few issues on Android, and RxJava solves a lot of them. We will see a perfectly working example. So just a little introduction. Reactive programming was an idea by Eric Meyer. He created Rx.net when he was in Microsoft. And a couple of years later, Brian Christensen, formerly at Netflix, released RxJava, and he saved us all. RxJava actually is targeting the virtual machine, so is Rx Clojure, Rx Scala, Rx Kotlin, Rx whatever. Right now we have RxJS, Rx Python. Everything is going reactive because it's cool. And that's most of the reason, because it's reactive extensions and not just RxJava. The main point is the data is a flow. So we are not asking, we are receiving the data. It enforces the concept of push versus pull, because we are subscribing to data, and the data will come to us when they are available. It's based on the observer pattern, the one from Django 4 observer pattern. It's old thing, but we never used it because it's kind of tricky in Java, and now we have it everywhere. Our life is based on the observer pattern, because we expect things that work in a specific way. We don't check the email, we get a notification. We don't check WhatsApp, we get a notification. Data is coming to us. The easiest example that you can say to your mother is the spreadsheet. We have a total cell, and we update a few data, and the total cell updates itself. We are not updating the cell manually. We are not checking that everything is in place. We just decided what will happen when the data changes. And Rx observer pattern, it's based on four most important players. The observable, that's the emitting one. It's the entity that generates the data. The observer and the subscriber are the receiving ends. They are waiting for the data, and they know what to do when the data comes in. If you want to go deeper, there is a talk for last week by Jake Wharton about subscriber, because turns out that everything is a subscriber in RxJava, and we have just a bunch of wrapper that makes things easier. The subject, it's the fancy one of the group, because it can be at the same time an observable and an observer. You can subscribe, and you can subscribe to it. It's handy in a few scenarios, and when you start using it, at some point you realize that most of the things that you do with the subject could be done with a proper observable observer pair, so you grow up as a professional. The observable and the observer communicate with an interface. We have three methods, basically: on next, on error, and on complete. When we generate the data, the observable push the data to the on next, and the observer receives the data and uses it. Basically, we got the data in the on next. The uncompleted is fired if the sequence is over and we are not receiving any more items. if something goes south, we receive a on error call. Going practical, we are going to create a standard Android app. It's a material design app with a recycle view and a list of installed apps. Piece of cake. So first thing first, how we do create an observable? We create a standard Java function that returns an observable of some type of object, some kind. We use the observable.create function to create the subscriber, the unsubscriber, the subscriber. We generate the data in a for loop for this example, and when we have a new item to propagate, we call the onNext and we push the data. When the sequence is completed, we use onComplete. So we are creating an observable from a list, iterating on the list. That's not the proper way. RxJava has a method for everything. So there is a proper method to create an observable list from a list. You just pass the list and you have an observable sequence of the type of the list. What if I only have 3 objects and I want to emit just those 3 objects? Guess what? Just. So we have an observable.just and we pass as arguments the object we want to emit to the sequence. What if we want something that, an observable that doesn't emit anything and just complete, empty? What if for any reason we want something that never completes? It's just looping, never. What if we want something that just goes south? Because for testing purpose, we are computer scientists, we like stuff that blows up, throws. There is a method for everything. So now we know how to create an observable. What now? How we subscribe? The example, we have the recycle view, we create an adapter, we have the fancy swipe refresh layout, and we create an observable from our apps list. We subscribe with an observer. The observer looks like this one. It's just an observer of app info. It implements an interface, so we have onNext, and we receive the object. When we receive the object, we add it to the list, and we refresh the adapter. When the sequence is over, we just show a toast. And when something goes south, we stop the recycle, the progress bar, and we show a toast message. Piece of cake. But the point is, why? Why should I learn RxJava if I just need to show a list? Because there is much more. Because we are working on a real job where things goes not always as we expected. We work with what we have most of the time. So we have this new boss that doesn't like apps that start with a name different with a C. We just want apps that start with C. We want to write as less as code as possible, so we don't want to change much. How do? We add filter. It's one line, it's a lambda because I'm using retro lambda. Most of you probably are using Java 8 or retro lambda, so the syntax is fine. We are filtering the sequence with a condition. Filter just evaluate the condition and returns a Boolean. Actually, it propagates the items that satisfy the condition. So in this case, start with C. And here is our new C named list. Piece of cake. What if we have a lazy boss that doesn't like long list? Take 3. And we just have a new list with 3 elements. What if we want the last 3 objects? Oh, by the way, the observer is always the same. So from now on, it's Jon Snow because it knows nothing. Because it just reacts to, he's waiting for an app info object. So why bother him? Our boss comes in and he's the kind of guy that jumps to the end of the thing. So we have to take just the last 3 elements of the list. Take last, surprise. And here is the new app. Jon Snow is always there. I have duplicates. So we have a list and we want to get rid of the duplicates. How can we do it? We can try to some iterator or comparator or something. No, we have RxJava. But in my installed apps list, we don't have duplicates because you can't install the same app with the same name more than once. So we create the list. We take 3 elements, we repeat the observable 3 times, so now we have a sequence of 9 items full of duplicates. So how do we get rid of the duplicates? We have the instinct. The instinct would simply mirror the previous observable and gives us only the value that come in once, so no duplicates. Jon Snow is always there. I add duplicates, but I'm living in a dynamic environment because the instinct works on a complete sequence because he has to pick the right elements. We have a current temperature sensor, is the easiest example. We have this sensor that is emitting the current temperature every second. But we are updating a display, so we don't want to over-update the display because it's just not effective. How do we do it? We use distinct until changed. Why not? It will mirror the previous observable and will create a new observable just with elements that are new. And we have just now. Okay, we have the sensor and we have a new, or at least we have an item every second, but the temperature is not changing so quickly. So we have to slow down. We want to slow down the rate. We use sample. Sample takes an amount and a time unit. Just know is always there. So basically, we create a new observable from the previous observable, and in a window of 30 seconds, we take the last item emitted. If we want the first item in the window, we use throttle first, because RxJava has a method for everything. There is an operator for everything, and there are endless operators, because you can create your own operator if you need. Transforming. Our OCD boss has a new requirement. He wants everything to be lowercase. So we want the same apps list, but we want it lowercase. We want to change not that much code, and we want to apply a function to every emitted item to make it lowercase. Surprise, map. Map is just applying a function to an object, to the emitted object, and returning something. In this case, we are returning the object itself. But we could, for instance, return only the bitmap. What if we have the whole list of app, but we want just the bitmaps? We could use map to extract map and return and instead of an app info object, we will return a bitmap object. at that point, Josno won't be able to understand anything because the observer will be different. They will be waiting for a different kind of object. RxJava has a huge amount of transformers. For instance, we have a flat map that it's the observable brother of the map. Basically, when you start using RxJava, you realize that you are going to create a lot of small observable functions. How do you chain them? You use flat map or concat map. If you need to cast for every reason the emitted item, you can use cast. If you are dealing with burp, sorry, the lunch was interesting. If you want to deal with list instead of single object, you can buffer them, and buffer will emit a list instead of the single object. Combining, we are going to use more than one observable. We have our list, and we have the same list reversed. How do we merge those sequences? Merge, yeah, rocket science. The observer is always the same. What if we are going to work with two different observables? We have our list, and we have a new observable that we create with an interval operator that is just emitting a long every second. We have a function, update title, that it's basically chaining the number and app info object, the title, actually. How do we merge all together? We use zip. Zip takes a certain amount of observable, up to 10, and a function to manipulate the objects. Android, that's the main issue, the MainThread issue. Probably it's this, you have in a Java world with JavaFX the same problem with the UI thread. It's a common issue. For this example, I'm going to read from the SD card. It's a common scenario. We are just retrieving something from a memory or a database or whatever, and we are creating a list of JSON, and we are emitting it. We are creating the data, we are creating the observable, we are getting the string with the shared preferences, we are emitting the list when it's ready, and we complete the sequence. Everything is fine. We are using RxJava, we are happy. Then we enable strict mode. Strict mode is a useful tool on Android that gives you a kind of reality check about how you suck being a programmer, because it reports strict mode violations. In this case, disk read violation. Basically, we are reading from the SD card in a blocking synchronous way, and we are wasting 200 and something milliseconds every time. So we are doing work on the UI thread. That means that the UI is stuck when we are reading. Try to imagine a network call. It will be even worse. How do we do it? We don't want to change much. We need to do the work on a different thread. Probably we could use async task. No. We have schedulers. We live in RxJava world. We just subscribe on a different scheduler. Schedulers.io. Basically, you tell RxJava to execute everything that is above the subscribe on a different scheduler. Schedulers.io basically provides you a thread pool for I/O operation. So we are cool. We are doing the job on a different thread. We are not getting the risk read violation anymore. We try again, and the app explodes because only the original thread that created the view hierarchy can touch its view. That makes sense because we are working away from the main thread, but we are updating the list. So we are doing the job on a different thread, but we need to be on the main thread when the data comes in. How do we do that? Probably the async task. Stop. We are working with RxJava, so we just ask RxJava to observe on the Android MainThread. And basically, with two-line of code, we are stepping off the main thread, doing the job, and going back to the main thread when the data comes in. Piece okay. Concurrency with 2 lines of code. You can use it for everything that's I/O related, network, database, whatever. This is just an example. What if I'm not doing I/O related stuff? We have this fancy create function that basically it's just wasting time. At some point, we launch the app and the method execute, and we get app is not responding. We got a skipped frames message. So how we do this? It's not I/O related. We have other schedulers. There are a bunch of them. In this case, we can use computation scheduler because we are doing CPU-bound operations. We can use immediate if you need to do the job on this very thread as soon as possible. Trampoline if you want to be queued at the end of the queue. A new thread if we are going to use a new thread. 2 lines of code. So this is the real-world example. We are going to create a real app using these tools. It's the classic, I'm asking stuff to a REST API and I'm populating a list in my Android app. Basically 90% of the app on the Play Store. We are using Retro Lambda because we are stuck to Java 6 on Android, but we like the little arrow, so I'm using Retro Lambda. I'm using Butterknife because there is just one man that can create an Android app without a library by Jake Wharton, and that man is Chuck Norris, and I'm not Chuck Norris. So we are using Butterknife by Jake Wharton. Lombok, because I'm too old to write manually getter and setters. I mean, really. Retrofit, because it's the only proper way to deal with a REST API on Android. It's by Square. They pay Jake Wharton, so still. We use a universal image loader. You could use Picasso, Glide, Fresco, whatever. It's just a library that retrieves images, and it's cool to use, it's easy, and it works. Here is the app. It's basically a list with an image, a couple of images. Actually, we are retrieving data from Stack Exchange. These are the most popular users on Stack Overflow. And for every user, we are retrieving the small icon for the weather from Open Weather Map. So we have 2 interfaces that map the REST API. This is Retrofit 1.9, by the way. They have a new 2.0 version. I didn't have time to update the slides, but yes, you should try it because it's really cool. It solves a few issues that the stable version has. So we just mapped the REST API. It's just that easy. I'm lazy, and I'm creating the JSON to Pojo, whatever, with the JSON schema to Pojo. I'm not, come on, really. I can create models manually. I'm too old. I'm creating Stack Exchange API Manager because it's cool. I like to think to have things sorted out. So we are creating a REST adapter. We have a get most popular SO users method because naming is everything. It's returning an observable because RxJava is supported out of box by Retrofit because, smart people. But the result that we got from the Stack Exchange API, it's not the perfect match with what we want. We want a list of users, so we apply a map. We got the result. We apply a map to extract the users. We do the job on the schedulers with the schedulers IO, and we got the result on the main thread. Piece of cake. Here is the Android part. It's basically, I'm not using dependency injection. You should use Dagger. I'm not using MVP. You should use a representer because it's the only way to properly test your Android apps, but it's for the sake of the presentation. So we have our adapter, the cycle view, we have the API manager, and we have this refresh list function that basically starts the progress bar, asks for the 10 most popular users, and when the data comes in, stop the progress bar and populate the list. If something goes wrong, stop the progress bar and print an error on the log cut. That's the app. 10 lines of code. We want the same drill for the forecast, so we create an API manager for open weather API. We do the same for the, it's haunting the timer thing. We created this get forecast by city method. We filter out the responses that are null or that are not quite what we want. And we concat map a new observable. That's the one that is retrieving the icon, because we are using another function that returns an observable or bitmap to do the fetching of the image. It's a network operation, so we use a scheduler.io, and when the bitmap comes in, we are on the Android MainThread, so we can change the UI and we can use the icon to set the image view. And we got the new version of the app in how many lines of code? We are dealing with networking, concurrency. We are firing up asynchronous tasks like it was no tomorrow. We don't deal with threads. We don't deal with, we are too old, and it's 2015. We can't do threading manually anymore. So it was very quick, and it's a huge topic. I could talk about RxJava for days. You will kill me, probably. But I hope you get the idea, or you have to stop to rely on getting the things when you want them, because it doesn't work anymore, because we are living in a fast world. The user can't wait for your network call to come in. It has to be able to do something else. So we subscribe. We subscribe and we decide what will happen when the data come in. We use a different approach. It's a mindset switch. It's hard to get at the beginning, but the moment you get it, it's done. You could do anything else, because the moment you think about, I'm going to read from the database, and they are giving you a list, you know that you are doing it synchronously. You are blocking everything. So why I'm not getting an observable of list? And I can do other stuff in the meantime. It's a flow. Data, it's a flow. It's a sequence. It's like rivers. They flow. You can filter a river, you can transform a river, you can combine two rivers into one river, and it will still flow. In the end, it will be the river you want it to be, because you work with what you have, but you need specific things, so you have to change the flow. And you can do it with a few lines of code. Be water. Thank you. Thank you for attending. And if you have a question, you can use 1 minute, or you can use Twitter, or you can use the app. Anybody has a question about reactive programming? Shoot.
Yeah, And even bus has not anything that you describe, but it has one very good quality, is that it decouples stuff. What from I understood from reactive programming, at some point, you have to have the two objects that you want to connect together at the same point, and it couples them together. How do you achieve decoupling with Rx?
So event bus, event bus gives you the opportunity to decoupling. Rx at some point you have the two object. If you start using the Rx the proper way, you can have interfaces, you can have single responsibility principle. You know, you have objects that do stuff, and you just ask for an observable, and you just ask for the data when they come in. You are not bounding everything together, because you're, like in the example, I was using the API manager, but I should use you should use a presenter that do the stuff. At some you have decoupling because you're using a proper architecture. It's not the technology itself that gives you the power. It's how you to use it's a tool. It's just a library, it's not a framework, for instance. You don't look satisfied.
Yeah, perhaps when you show me an example of code, I will realize what you're telling me. But,
I will make the source code available on my. The source code comes from my book, so it's available. I will be available on GitHub in a few days. So you will have a real example, but it's just this one, you know, because this is the real world actually. You just ask for data and you subscribe politely, and when the data comes in, you got it.